So what we're looking at here is a standard inequality setup where we've got two equations with an inequality, which is just fancy math talk for a symbol of a greater than, less than, greater than or equal to, less than or equal to going on in the middle. And we could definitely solve this by hand just doing some algebra, but it's a great opportunity for us, again, to learn some calculator skills now that we can end up using throughout the rest of all of our PACE course life. So well, that's exactly what we're going to do. This is, if you've seen any of my earlier videos, or later on you'll see hopefully some of my other videos where this is what I would call the first cousin of the something equals something setup. And so what that means is we're going to take and put our first something here, this 3x plus 4, into y1 on our calculator. And then in y2 we're going to put our second equation. And the key here, what makes it similar but not the same as the standard something equals something, is we want to go ahead and we're going to end up shading y2. And whenever you do one of these inequality problems, you always shade y2. When we talk about shading, the shading is going to be based upon the inequality that's given to us in the problem. So if the problem is a greater than problem, we're going to want to shade up in that situation. If the problem is a less than problem, we are going to want to go ahead and shade down. And this wouldn't matter if it was greater than or equal to or less than or equal to. We really want to shade based upon the first part of the symbol. So for us, we've got a greater than symbol, so we're going to end up doing the shade up in this situation. And so once we graph that and shade it, we're then just going to go through our calc intersect process like you would on a something equals something problem, where you would just then go second calc intersect. And how I tell which of the options I want below here is I always just say that good answers live in the shade. And so when we look at the graph, we're going to have the first equation going into the shade of the second equation. And if we want if the shade is going to the right, then we'd be looking at the top answer here. And if it's headed off into the left, so if we're looking at something that's headed off this direction into the shade, we're going to be looking at the first option. And if we have something that's going off in the left direction into the shade, then we'd be looking at the second option. And so what we're going to do is we're now going to pull up our calculator, and we're going to go into our y equals. So that's the top left button there. You just want to hit y equals. And in y1, we're going to type in our 3x plus 4. And then go down to y2. And in y2, we're going to type in negative 6x minus 9. And to shade on these calculators, if you're using any of the calculators, you just want to scroll all the way over to the left-hand side. If you're on the older calculators, you just want to hit enter a couple of times until you get the shade matching up, either the greater than or less than, depending upon what your problem says. For the more modern calculators and the calculators you'll see in the testing center, you just want to go ahead and hit enter on that right now. And it's going to give us a choice down below here of what type of line. So when we choose our line, we could choose either the greater than symbol, which is what I just switched to right now, or we could choose the less than. And to do this on the older calculators, you're just going to hit enter until you get the shade direction that you're looking for, either greater than or less than. So for us, again, we're looking for the greater than in this situation, so we want to shade up. And so once we have that, we're just going to go ahead and hit enter until we get out of there. And now we're going to graph this. And there's our first curve, and there's our second curve. And so what we can see is sitting right there in the middle is our intersect. And based upon the fact that good answers live in the shade, we can see that our intersect, so we'll calculate that intersect. So you want to go second, and then the calc button is up above trace, calc, and then number 5, which is intersect. And it's going to ask us 3 questions, and the first 2 questions we could care less about. Just hit enter. Is that the first curve is what it's asking? Yep, that's the first curve. Is that the second curve? It automatically switched to the second curve for us, so just hit enter. And then guess, we've only got one intersect, but we could go ahead and scroll up so we're closer to that intersect right there and hit enter. And so what we can see is that the blue graph, our first graph, enters the shade of the second graph at that intersect, and from that point everything to the right is what we would be looking at. And so what we want here is our first option, because if you notice the pictures that I drew at the very beginning, you can see that I drew what the graph should be doing. And so what we've got here is we've got the first graph is headed up and to the right into the shade of the second graph. And so we're going to take our x equals 1.44 and we're going to enter it into this option here. So we would want x is going to be greater than 1.444. And again, before you finish up on any of this, what you always want to do is you're going to want to go ahead and calculate the number of decimal places that you're looking for, because depending upon the problem, it'll either ask for 1, 2, or 3, and it's kind of the little test within the test. So our answer would have been x is greater than 1.444.